Hi everyone, welcome to today's class. So this is my topic number 14, and for topic number 14 I have chosen Carnot cycle from chemical thermodynamics. So you all know what Carnot cycle is because in BSc chemistry that portion was there, and that time also it was very important. And now actually we will cover the what Carnot cycle is and the mainly the questions PYQs which are asked from this topic. So this from this portion of chemical thermodynamics, actually questions are asked, and mainly the graphical representation and the efficiency of Carnot cycle is very important for question. And if you understand the topic, if you understand the chemical thermodynamics, the systems, various kind of systems like adiabatic process, various process like adiabatic, isothermal, what is the what formula for that. So if you understand clearly those topics, you can actually understand it in a good way, okay, easy way. And I have previously uploaded a few videos from chemical thermodynamics, and where I have taught you the basics of thermodynamics and also the work formulas. If you have not watched this video, please watch that videos first, so that you have a clear understanding of this topic. Okay, so let's just start it. So let's get started. So first, the Carnot cycle. So what is Carnot cycle or Carnot engine? So cycle is the graphical representation, and actually the process is this is for Carnot engine. Okay. So this is actually a hypothetical ideal. First ideal, that's why it is hypothetical, because we know that we for our understanding purpose, or the derivation will be easier for in every cases if we take the ideal gas. But ideal gas, so in reality we cannot in nature also. So the ideal condition is actually a bit difficult to attain. Okay, so whenever ideal situations are or conditions are there, that must be hypothetical. Okay, and it is reversible process. All the process in Carnot cycle it is reversible process. Okay, this is cyclic process, which means the starting point and the ending point are same, and it is spontaneous process, and the efficiency is theoretically possible maximum. Okay, so the efficiency of Carnot cycle is theoretically possible maximum among the all the engines. Okay, now the diagram of Carnot cycle, how actually it works. So this is a heat source, we will say. Okay, this is heat source and this is heat sink. Means it has higher temperature where from where heat is actually coming to heat engine, and this is the heat sink where heat engine removes some or releases some heat. Uh, that is the heat engine. Okay, and by accepting or by absorbing some heat from heat, by taking some heat from heat source, it gives you the work. Okay, so that is the simple process of heat engine. So it absorbs some heat, and it do some work. It does some work, and it actually releases some of the heat, not all, some of the heat. Okay, fine. Now this will is the graph of Carnot cycle. So four processes are there: one, two, three, and four. Okay. So among the four processes, two are isothermal. So those two are one and three. Okay. So we can write 1 to 2 and 3 to 4. Okay. 1 to 2 and 3 to 4 are reversible process, and 2 to 3 and 1 to 4 are adiabatic process. All processes are reversible. What I told just now, that all processes are reversible. Okay, So it is isothermal reversible. Isothermal, two are isothermal and two are adiabatic, which are 2 and 4. 2, 4, 1, fine. Both are reversible. Isothermal reversible, adiabatic reversible. Okay. What are the other important things? So one point is that. Second point is two processes among these, or two steps are the expansion step and two are the compression step. So in this process, if you see, this is the volume in y-axis, right? Y-axis is the volume. So 1 to 2, here volume increases. So obviously expansion processes are. So you have to have the clear idea about these simple things. Okay. So because some tricky questions from graph can be asked in Carnot cycle. Okay. So you have to have the idea about these things. So expansion 1 to 2. And I said two expansion steps are there. So one is this. This is 1 and 2 to 3. See, little increase of volume is there because 2 is here, let's say here, and 3 is here. So volume is high here, okay, higher in here. So 2 to 3. So 1 and 2 are expansion. So compression will be obviously, so let's say this is 1, 2. So expansion is this, compression. Okay, compression will be, okay, 3 to 4 and 4 to 1. See, 3 to 4 volume decreases, 4 to 1 also volume decreases, which means that step 3 and step 4 these are compression. Okay, fine. And one important thing is that here, if I remove this one, so this is one process, one. Okay, heat is absorbed from source. Here you see now, source is present, one source is present. So from source, here heat is absorbed here, Q1. Okay, and this is isothermal process. This is adiabatic. So in adiabatic process, we know delta Q is 0. So here no heat will be absorbed or released. Fine. Again 3 to 4 is isothermal. Here heat will be released. Q2 amount of heat will be released and Q1 will be absorbed. Fine. Okay. And this is again adiabatic, so delta Q will be 0. And for isothermal process, what is constant? T is constant. So for isothermal process, delta T will be 0 for these two. And for here, delta Q will be 0. Okay. And if delta Q, okay, I will I will talk about the other things, other parts like the U, okay, H, and also work in the next slide. So right now just this much, and starting point is, let's say 1 if we take. So starting with the isothermal reversible expansion, then adiabatic reversible expansion, then isothermal reversible compression, adiabatic reversible compression. Okay, so starting point is 1 and the ending point is also 1. Fine, we have understood this. Now coming to the step 1, isothermal reversible expansion of ideal gas. Okay, so this. Okay, so first thing is that you have to know in all the steps which are actually changing and which are constant. You have to have that clear idea. Okay, so isothermal process, A to B, and A has P1 V1 TH, let's say, and B at point B P2 V2 TH. P2 V2 changes but TH doesn't. Why? Because here what is happening? Here what is happening? Delta T is 0. Okay. Now what is happening? Here delta T is 0 as isothermal process. So the final and initial temperatures are same. Fine. Now as it is expansion, V2 will be greater than 0. And opposite will be true. P1 will be greater than 0. Fine. No other thing we can tell right now. Just let's see the other important parameters. Okay. We know from thermodynamic first law, du equal to dw plus dq. I have uploaded videos for that also. Please watch it. So du equal to U is internal energy and W is work, Q is heat. And we know du equal to CVDT. I have also uploaded one video regarding these things, these important formulas and specific heat capacity. Okay, CPCV. So please watch that video also. So du equal to CVDT. But here in isothermal process we know dt equal to 0. So obviously du will be 0, right? So what we got in this process, du is 0, dt is 0, du is 0. Okay. So now if we put du is 0 here, dw plus dq1, q1 amount of heat is actually taken by the system here, q1. Fine. So q1 dq1 will be minus dw. And we know for reversible isothermal case, the work formula is W1, let's say, will be minus nRT ln d final by d initial. Here d final is V2, d initial is V1, and nR, n let's say mole, number of moles, and TH is the temperature which is constant for this process. Fine. And now Q1 will be only the negative sign will be not there. So nRT H ln V2 by V1. Fine. These are the important formulas. If you know how to actually write the work formulas and what are the work formulas for adiabatic and isothermal cases, this will be easy for you. Okay. So that's why I am again and again telling you, please watch the previous videos first of thermodynamics. Okay. So now what are the, okay, we know now W and Q, and another one is left here is delta H. If someone asked you about enthalpy, what will be? dH equal to CPDT or NCPDT. Okay, again dt is 0, so dH will be also 0. Here, right, dH equal to 0. dH is also 0, du is also 0, but work is this and Q is the opposite sign of work. Fine, this we got till now. And entropy, okay, entropy factor, what will be the entropy? Entropy I did not teach you till now. So entropy is actually Q reversible by T or dq by dt. Okay. So here Q is Q1 taken, heat is taken Q1 and T is dH. And as heat is taken and okay, here if you see the V2 is V2. This is expansion, right? So what will be the sign of work and the heat if we want to know? V2 is greater than V1. So ln part will be positive and here negative sign is there. So W1 will be negative. Work done by the system. Fine. And here this is positive. So overall term will be Q1 is positive. We actually want this only because Q is absorbed. When when heat is absorbed, it is positive, and heat is released, it is negative. Okay, please remember this. So here it is actually absorbed. So this is actually correct here. So we are going correct, right? And here, as Q1 is positive, delta S also will be positive. Okay, so delta AC is positive. When I will show you how we can represent the graphs for entropy versus T or something like that, then we will understand in a better way. But please make sure that you understood here till here. Okay, because nothing, we are just taking that what is the system, what is the process, and after that we are just concluding what will be now for this process. Okay, now next I will go faster, okay, because you know everything. Adiabatic reversible expansion of ideal gas, second step, which is B to C. In B case, what was that? P2 V2 TH, it was there. And when we reach C, that will be the PV, obviously it will be changed, right? P3 V3 and here PC, because temperature is also changed. Here adiabatic process, we know dq is 0. Okay, we know that dq is 0, delta q. So heat is not transferred, but temperature can be changed, right? This is not isothermal process. So let's say temperature is this. So temperature will be higher than the initial or not, that we don't know. But now if you see that here in the system, let's imagine a system, and this is actually adiabatic walls are there, insulator kind of walls, so that heat can't pass through walls. So delta Q is 0 here. No heat is absorbed or released. Okay. Now, if the process actually expands, expansion going on, that will result actually cooling of the system. Okay. So this is general process actually. This is a common phenomena, and we can prove that also. But right now, just see that whenever a system is closed, heat is not going, cannot going outside, and we can't absorb also heat, and expansion is going on. So that means the system using its internal energy, okay, through it uses its internal energy, and work done by the system is going on. Okay, so work is done by the system and it expands. That time heat will be, so cooling will be there. Okay, so so Tc is less than Th. Fine, we understood till this. Now from the first law we know du equal to dw plus dq, and here dq is 0. Obviously du equal to dw, right? Now du equal to dw. Okay, now we can write, as we know that u delta u is CVDT, and here obviously temperature is changed, not constant. So CVDT means T final by T minus T initial, Tc minus Th. Okay, it will be equal to W. Here work sign will be what? Here Tc is less than Th. Obviously work will be, W2 will be negative. That means again work done by the system, okay, which leads to cooling. Okay, now so here, oh, here what we got actually, just write that. Okay, first delta Q is 0, fine. Delta T is not 0, but cooling takes place, fine. As delta Q is 0, delta U will be equal to delta W, and we know these values. Okay. Next, delta H will be, okay, here delta U also will be negative. Okay, U will be also negative. Fine. Delta H, CPDT means this one again it will be negative. Okay, negative. Here it is also negative. And S, delta S is Q reversible by T, as it doesn't take any heat or it doesn't give any heat, it will be 0. Q is 0, so S will be 0. Fine. Next, isothermal reversible compression of ideal gas. It will be same like step 1, but here the only difference is compression. It will go on. Okay. So if it is C to D, so at C we know P3, V3, Tc was there, and as it is isothermal, we know dt will be 0, delta T will be 0. So Tc and Tc final and initial will be same, and P3, V3, Tc and P4, V4, Tc is same. Fine. Now what can we write? As it is compression, V3 will be greater than V4. Okay, that will be used in the work formula obviously. Okay, now du equal to cv dt we know. Okay, du equal to cv dt and dt here 0, so du will be 0. Fine. If we put the du 0, then will be again the same like previous. Q2 will be minus dw. Fine. And for the isothermal reversible case, we know W will be minus nRT ln V final by V initial, and here minus nR Tc will be the temperature now ln V4 by V3, as V4 is the final and V3 is the initial volume. Fine. It will be like this, and Q will be negative of this. So here negative sign was there, and it will be now just positive. Okay. Now the changes are we have to know the sign. Okay, so we know that V3 is greater than V4. Okay, so upper term is lower than this V3. Okay, so it will be ln less than 1 V4 by V3, and ln less than 1 value will be negative. It is negative. So here it is negative, and in front of this actually negative sign is present, so it will be overall positive. W is positive, so here work done on the system will be there. Okay, sometimes these questions are also can be asked. Okay, so you have to have the idea of the all things which we have read about, and which are actually changed in the when we vary the systems. Okay, and the conditions. Okay. So dq will be, or q2 will be what? Q2 will be here V4 is less than V3, Q2 will be negative. And we know in this process actually heat is released to the sink, Q2 amount of heat. Fine. And again the like previously which we done actually here, what we got? Delta T equal to 0, delta U equal to 0, delta H also will be 0, right? And delta S, what will be the delta S? See, here I am writing. Delta S is delta Q reversible by T, and here heat is released, and Q is negative. Here also we got Q is negative, dq, Q2. So delta S will be also negative. These are actually important things. Okay, so you don't have to remember anything, you just have to remember that step 1 is what, step 2 is what, and step 3 is what, and you have to have the idea about the work formulas and how can we relate, like thermodynamic first law is important here, and dq equal to cv dt and delta is equal to cp dt. These kind of things are, if you know, you can actually have the idea about the all kind of these parameters. Okay, so now the last step, adiabatic reversible compression of ideal gas. Compression is going on and rest things are same like adiabatic. Okay, P4, V4, Tc is there, and adiabatic case, so it will be again pH at A point. We know that. So now V4 is greater than V1 because compression is going on, and Tc will be here higher than TH. No, this is not right. Here cooling was going on, so TH was greater than TC. Yes. So again the same thing will be there. Yes. So TH will be greater than TC. Okay. Now we know again first law. Okay. From that dq equal to 0 and dw will be equal to du and cv dt. So T final minus T initial, and here TH is greater than TC. So U will be positive and also work will be positive. So here also work is done on the system. Okay. And as okay, what we can write again the other things about the other parameters. Okay, delta S, let's say delta is again Q reversible by T, but here as it is adiabatic process, dq will be 0, so delta S will be also 0. And delta H, what about delta H? Delta H is CPdt, dt is positive, so delta H will be also positive. So what we got here, delta Q is 0, okay, delta T is positive, delta H will be positive, and W is positive and U is positive. Okay, please write in your copy in a clear manner. Okay, so now we know the 4 steps, right? Yes, 4 steps we know. Now we have to calculate the total work. Total work will be obviously for cyclic process W1 plus W2 plus W3 plus W4. Okay, and I have put all the work formulas here which we got till now. Now, what will be the case for, okay, for B to C change? B to C change is adiabatic, and for adiabatic process we know that THV2, this one, THV2 to the power gamma minus 1 will be equal to TCV3 to the power gamma minus 1, obviously. And what we can write from here? We can write that V2 by V3 to the power gamma minus 1 will be TC by TH. Fine. And for the next step, next adiabatic step, D2A. Okay. For this change, we can write this one. And from this, we can write that V1, V4 gamma minus 1 will be equal to the TH TC by TH. Fine. So if we compare these two equations, you see the right hand side part is same. So we can actually equalize these two, and after when we equalize these two, we will get V2 by V3 equal to V1 by V4, and we can write V2 by V1 will be equal to V2 by V1 will be equal to V3 by V4. Okay, this one we can write here. I have written it. Okay, let's just remove the other part so that you can see in a better way. Okay, so this till this we got. Now what to do with this value? Why we are doing this? Because we want to simplify this whole equation. Okay, if you put the value of V3 by V4 here, we can actually simplify the equation, but here is we can't see the V3 by V4, so we have to actually reverse it and take a positive sign. So for work we can write minus nRTH ln V2 by V1 plus CV TC minus TH plus, it will be plus now, nR TC ln V3 by V4, and we can take negative as common and CV TC minus TH. Okay, I hope you can see here. I will just cut it down, this one and this one. Okay, so this term I will write in the below. I think you can't see that. Okay, so minus CV TC minus TH. I've just taken this one opposite so that I can cut it. Okay, so it will be cancelled out, right? And here, okay, V3 by V4 is now here, so we can write minus nr, if we take that common, th ln v2 by v1, and here also it will be plus nr is taken as a common, tc ln, it will be also v2 by v1. After putting this value, this one, now we can write work we have actually simplified. We got na simplified equation. So just see that. Right? So this will be the work formula now. Okay? So minus nr th minus tc. th is the temperature of the source, temperature of the sink is tc, and ln v2 by v1. Okay? And we also can write here that minus nr th minus tc and ln, what we can write, v3 by v4. That also we can write. Fine. We got the simplified value of 1. Okay. Now coming to the efficiency of Carnot engine. This is also very important. Many questions are actually asked from this topic. So now we know Q1, Q2 is this. We will be needing this. That's why it is in slide. So the efficiency is the ratio of output work and input energy. Input, for input, what we give the heat from source. Okay, so Q1. So eta will be output by input, and eta will be work done by the system. This is the output, and heat absorbed. Okay, it will be minus W, work done by the system, so minus W, and Q1, heat absorbed is Q1. Now we can put the value of overall work, and Q1 was, the value of Q1 was this one. This one we have write it down. Now that will be cancel out this one and this one, and inner and inner. So this will be now the efficiency. We can also further simplify it by let's say we have put the this value Q1 plus Q2. So it will be when we take Q1 plus Q2. Okay, just I'm doing below here. Okay. If we take here Q1 plus Q2, what will be here? What will we got? Inner ln. Okay, and here if we write, okay, let's just simplify that. Inner is I have taken common. So now TC is there. So now TC is there, right? And ln, let's say I have taken minus, and v3 by v4 I have written like that, and plus th ln v2 by v1, and we know that v3 by v4 is equal to v2 by v1, right? And if we put that value, it will be nr into th minus tc into ln v2 by v1 I have taken as common. This will be the Q1 plus Q2. And if we take Q1, if we divide Q1 here, so nr th and ln v2 by v1. That is there. This will be cancelled out, and overall this will be also cancel out. Overall this will be th minus tc by th. Okay. If you put the value of Q1, Q2 here, you got again the same thing. So this is an important equation. To here see the only the here the equation. The equation there are the temperature of the so efficiency depends on the temperature of the source and sink. Okay, and here we have related the Q1, Q2, the heat absorbed and heat released with that. Okay, and mainly efficiency is minus W by Q1. We can equalize the whole. Fine. So some important facts about the efficiency is that efficiency doesn't depend on the working substance. It only depends on the source and sink of temperature, and eta will be less than 1 always. So how can we say that? So let's say if eta is 1, let's say if eta is 1. If we put the 1 value, TH minus TC will be equal to TH, right? If we put it eta equal to 1, now the when eta will be equal to 1, okay. Now TC will be, yes, so now TC will be what? TH minus TH means 0. So the sink temperature will be then 0, but it is not possible. Sink temperature will never be 0. Okay, and so not possible. We can write not possible here. Not possible. Not possible. Okay, and also if we have taken TH infinite, for that case also eta will be 1. But that is also not possible. Second case, that is also not possible. This is the first case. Not possible. Not possible. And third case can be if TC equal to TH. If we take TC equal to TH, then eta will be 0. Eta will be 0. But this is also not possible, they are saying. So for every cases, the eta will be, it will be not 1, obviously, it will be less than 1. It will be actually greater than 0 and less than 1. So it will be less than 1, we can say simply. Now plots of Carnot engine. I will show you some plots. So T versus V, or U versus V, or H versus V, or I have written why, because this plot and this plot and this plot will be like same. Okay, so Carnot cycle has 4 steps. We know right now, by now, right? One is isothermal expansion, reversible obviously. So for isothermal expansion, dt is 0. So dt is 0 here, and volume is dv will be positive. Okay, let's say for second case. Okay, we again do the same for u and h. I'll show you just now. Right now I am doing that only. Okay, addia and expansion, right? So when addia is there, what was the for the second case? Cooling takes place, right? Because adiabatic expansion was going on, and for expansion actually work is done by the system, and it takes its internal energy to do that, and it will be now cooled down. So dt is negative and dv is positive. Fine. 3. Iso compression. Compression means, okay, first dt is 0, and compression means dv will be negative. Fourth, the addia compression. What will be here now? Addia means addia compression. Okay, so addia compression, dt will be here positive. Okay, the opposite of second, and dv will be negative. So how can we plot it? Okay, so in the first, if you see, if we take t and v here, t versus v we are plotting, and dt will be 0 for the first case, and dv is positive. In the second case, dv is positive again, so we can write like, we can plot it like dv is 0, dt is 0 means it will be parallel to x-axis like this. Okay, and dv is positive here to this, a to b, let's say. Fine. From B to C, what will happen for adiabatic case? dt is negative. Oh, okay. Dt is negative here, right? We can't do like that. So we have to take AB here. Okay. It will be again parallel to x-axis, obviously. But now we can draw in a better way. Okay. A to B, this one. Now from B to C, what will happen? dt is negative and dv is positive. Okay, dt is negative, dv is positive. So it will be like this. dv is positive here, see, and dt is negative. Temperature is decreasing, right? For the next step, we will see CD. What will happen? This one, dt is 0 again, dv is negative. dv negative means we have to go this way, and dt is now 0. So sorry, this will be again the parallel to x-axis. Parallel to x-axis it will be. Okay, I am trying to draw this one, and then it will be dt positive. The last step, dt positive and dv negative. dv negative means we have to go like this way, so that dv will be negative this way. Okay, and dt is positive. Fine. 1, 2, 3, and 4. And why we are saying that u versus b will be also same and h versus b will be also same? Because b is same here and u is actually proportional to dt, temperature change, right? Because du equal to cv dt and dh equal to cp dt. So if this kind of plots u versus v or h versus v, these plots are asked, then also same plot will be there. Answer. Okay. Next, h versus s. H is here, S is here. So first is iso expansion, right? And here iso expansion. Okay, dt is 0, delta H will be 0. And S, we know in the first step Q1 is positive, delta Q is actually equal to positive. It is absorbed. So delta S will be positive or increase. Second step, adia expansion. Fine. For adia expansion, we know dq equal to 0, and we know delta S is q reversible by t, which means it will be 0. And as it is actually the temperature has changed and cooling takes place actually. Okay, Tc will be, the final temperature will be less than Th. We have read about it, right? Cooling takes place. So cooling takes place means delta H equal to Cp dt, and dt is negative here, so delta H will be negative here. Okay, so delta S is 0, delta H will be negative. Okay, third case, which is uh, isocompression, right? So for the isocompression step, again Q is changed but it is released. So delta Q will be negative. So delta S will be also negative, decreasing this one. And what about delta H? Isothermal process, delta T will be 0. That means delta H will be. Now we have all the data, all the changes. No, sorry, fourth step is present. Fourth step is adia compression, which means delta T will be now greater than 0. It increases, which means delta H will be now positive. And adiabatic process, delta S will be 0. So we got the 4 values, this one, this, and this. Okay. First, A step, one step. Delta H is 0, delta F is positive. Means this can be fine. Now in the next step, this is 1, A to B. This will be parallel to x-axis. Okay. Now B to C. Delta F is 0, means it will not change, it will be parallel to y-axis, and delta H, what about delta H? It is negative. Simple, it will be like this. See? And third thing, delta S is negative, it will be decreased, and delta H is 0. So it will be like this way and parallel to x-axis, and the last step also will be parallel to y-axis, because the delta H is now positive, it is increasing here this way, okay, this way, and delta S is 0. So this will be the H2S diagram. Fine, you have understood this. Now coming to the question. A Carnot engine takes up 90 joule of heat from the source and kept at source. So source temperature it is TH 300 K, and it takes heat, means Q1 is 90 joule. Fine. The correct statement among the following is, it transfers what heat and to the sink temperature. So we have to have the have to find out the TC and Q2. This is your task. Sorry, it is not 0. We have to find out. These two we have to find out. Fine. So first we know that eta, efficiency. We can relate this temperature and heat via efficiency. Obviously, it was TH minus TC by TH equal to Q1 plus Q2 by Q1, right? So now, okay, if we take 1 minus Tc by Th, then it will be 1 plus Q2 by Q1, and the the equation we got is Tc by Th will be minus Q2 by Q. Okay, this is the equation. This is the relation we got. Now, okay, we can write from here also. What we can write? Tc by Q2 equal to minus Th by Q1. So Tc is the temperature of the sink. Heat released to the sink, and it is temperature of the source, heat absorbed from the source. We can relate these two. Now what we got, what values? We know that Th value. Okay, Th value we got. So Th 300 and Q1. From that actually we are writing. Q1 is 90. So the ratio will be 3, 10. 10 by 3. So we have to find out from the 4 options, we have to find out one option where Tc by Q2, because these two ratios are same, right? And negative sign is there because one heat is absorbed and one is released. Fine. So forget about the negative sign. We have to take the values only. So these two ratios are as same. We have to, from these options, we have to find out those values which actually can get this ratio 10 by 3. So let's say one option, it transfers what heat? So sorry, it was Tc by Q2, right? So we have to first write the Tc value. It was what? 200 K. 200 K, and the temperature, heat is this. Yes, we got. Okay, let's see one other option, just one. For the case of B, it is 200 by 50. So it doesn't match. It will be 4. But here 10 by 3 and 10 by 3, we could match it. So option will be 1. See how easy this is. This is CSIR-NET December 2012 question. Okay, but this is very easy. So if you remember those formulas, see right now I have derived that one. If you know this formula only, you can derive till this. Okay. Next, the figure below describes how a Carnot engine works. Fine. It starts from a adiabatic compression step denoted by what? So, adiabatic compression step denoted by what? Okay. So, see, first, what difference? So we know Carnot engine is look like this only. This is the isothermal, this is adiabatic, this is isothermal, this is adiabatic, like that. Okay. But same kind of graphs you can see, but here see main difference is here x is the in the y-axis there is volume, and in the x-axis there is pressure. Okay, so we have to, because in the Carnot engine it was PV graph, so we have to convert it to PV. How can we do that? We can do that by the first, there is a process. Okay, first actually we have to sorry, we have to take the mirror image. Okay, it will be easier if I take this in right hand side. Okay, so first will be mirror image. You all know what, how and we can write actually mirror image, how we can draw. So this is there, and A to D. Okay, so this is sorry, this is A to D. A is upside, D is downside, right? So it will be little down. D, let's say. Okay, D to C is what? D to C will be this. D to C is this, and D to C is this. C to B, C to B will be this one, like this one, and A to D will be this one. So A, B, C, D. Okay. Right now the process is we have to rotate it like this, so that it will be go upside and it will be look like this. And now we can see the P versus P graph. Okay. So right now we can see the P versus P graph, and it will look like, again if we move it, so it will be this, 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 and this. Okay, and this will be actually when it goes upside, CD, which is B, and this is A. Fine. So now we know this is now the Carnot cycle, we can say PV, and here it is written that it starts from a adiabatic compression state, which is the now adiabatic compression we have to find out. So we know this one step is, this one is isothermal expansion, this two one is adiabatic expansion, three is isothermal compression, and fourth step is the adiabatic compression. So correct option will be BC step. BC step. So you have understood this. First take the mirror image. Let's say here mirror is present, and first take the mirror image, then just rotate it so that you have the PV graph. Okay. So first, whenever a question is given like Carnot engine, and if you have to compare between the steps or something, you first see that what versus what is given. Okay. So this is a one kind of question that is asked in CSIR-NET June 2016. Now another kind of question is there. This is this. Carnot engine operates 55% efficiency. If the temperature of reject steam is this, then the absolute temperature of input steam is what? So Carnot system, what is given? Just write that. It is a question of date. 55% means 55 by 100. Eta is equal to. If the temperature of reject steam means reject, where we reject actually in C. So this is T2. It is 105 plus 273. That means it is P, this one. Okay? Yes. Yeah. This is the T2. This is given. Then the absolute temperature of input steam we want. Input steam means source. So T1, or it is TC, TH we have to find. Okay? We know eta is what? TH minus TC by TH. And we know that efficiency is 55 by 100. And we can put the value of TC here. Yes, we can also simplify this. like that way. 1 minus Tc by Th will be equal to 55 by 100, and 1 minus Tc value is given 378 by Th will be equal to 55 by 100. Now we can solve it. I have simplified for you, so you can solve it and calculate the answer. Okay, fine. So, now more questions are there. Okay, so yes, no more questions are there. So one question was there actually. Okay, so one question was there. So from the graph actually again. So if you want to know the various graphs are actually given. This is also a question of gate. So various graphs are given and you have to find out the Carnot cycle. What is the Carnot cycle graph? Okay. So PV graph is given, but PV graph looks like this. This. So we know that PV, for PV this kind of graph is there. So it will be not the answer. But in on one option there was one S and T graph that is looks like this. Okay, this kind of graph, that will be the answer. Why? So in isothermal case, let's say first step isothermal case, that Q is now positive, is to T graph. Let's say they have started with, they have not given a starting point. Okay, so in first step we know dt, isothermal case, dt will be 0 and S will be positive. Yes, so let's say this is the first step, it is matching. So in the first step dt is 0, delta S will be positive. In the second step delta S will be 0 and sorry, this will be not the second step, this will be the second step where delta S is 0 and no, let's see the twist. Okay, so in this step, in the second step, what is happening? Cooling was there, na? Adiabatic expansion, cooling was there. So delta T must be negative. This can be there, this can be there. But in the first step, it is delta S should be positive in the first step and delta T is 0. So if we take delta T is positive, delta S is positive, okay. If we take this one, yes. If we take this one, delta S is positive, delta T is 0. First step. Second step, what is happening? Delta T is negative and delta S is 0, adiabatic case. And in the next third step, it was isothermal compression. Delta T was 0 and delta S was negative because it was released from here Q2 and here it is absorbed Q1. Okay, you have understood, right? So this kind of graph, and the last step, delta S adiabatic case, delta S will be 0 and delta T will be positive. So this is now 1, this is 2, this is 3, this is 4. These kind of tricky questions can be asked from the graph. Hope you understand this. So you have to just two step, if you remember that first two step. So you have to arrange that what is the beginning point of this graph. Beginning point means where the isothermal reversible expansion is going on from this. Okay, so this graph will be from A, B, C like this. Okay, here it is given delta S is positive and delta T is 0. Fine. So S to T graph will look like this. It will look like this, and starting point will be here A, B, C, D, and this will be like this. Okay, fine. So it is completed now. It is also a gate question, some gate PYQ actually it is. So I have told you that also. So various kind of questions I have taken and I have shown to you. by solving this in a simple manner. So hope you understood this lecture, and if you have any query, please write it down in the comment section. I will help you out. And thank you for listening to my lecture. Uh, okay, see you in the next video.